Wonderful. Well, thank you all for being here today, and thank you to all of our attendees who are joining us. I think we're going to have people keep rolling in for a little while, but I wanted to get started so that I can do a brief introduction for people who have not attended one of these events before. As many of you know, I'm Dr. Alice Stanton. I am a postdoc at MIT. I'm a bioengineer, and I started STEM XX Chats with a group of young women who similarly want to help advance women in STEM. And our goal is really to create an ecosystem of empowerment for women in STEM. We're really excited to break down barriers. I think there's a lot of opportunities in each of our schools and institutions and other organizations, but there's really a lack of communication often, and especially between top women in STEM trickling into grad school, undergrad, high school, right? As a high school student, it can be really hard to get access to a lot of things. So we're really here to break down those barriers, and also to break down barriers between locations and fields, right? Often we don't get a lot of opportunities to dialogue between different disciplines. So we're really excited to make that possible, and especially to empower young women who really want to be positive change makers in the world. And so through a mix of content and events such as this one, and our core groups that meet every other week to kind of dig deeper into stuff, we're making all this hopefully a reality. And our organization is largely run by students. So we're trying as much as possible to have young women students be the driving force behind all of this. But we're really excited to be joined by awesome professionals, such as the ones who are in this panel tonight. And as a bit of a preview, so here we are, September 16th, and this is Academia versus Company, part of our Career Decision series. We have some upcoming panels that are going to be somewhat related. So consulting, if you're interested in consulting, that panel's in November. And then we have one in education in December. Our next panel in October actually focuses for high school students on choosing a college for STEM. So if you're a high school student out there, definitely tune in for that. And in parallel with our panel series, we have an interview series. Our next interview is with Professor Shirley Tilghman, who's the former president of Princeton University and is really a world-renowned molecular biologist, and a really awesome person. So we're really lucky to have Shirley joining us in 2 weeks. And we'll also this semester be joined by Paula Hammond of MIT and Tina Seelig of Stanford / TED / she's best known for her perhaps work in creativity, innovation, and entrepreneurship. And so she's really a wealth of information and knowledge. So we look forward to that as well. So that's a bit of a preview of what's to come. If you want to get involved in any way, we'd love to hear from you. I think you can follow us for starters on Instagram and Twitter, subscribe to our YouTube channel. YouTube, we post more content related stuff and recordings from panels when we can. If you want to get on the email list, there's the link there. And we also started a form that I'll put in the chat. It's to all panelists and attendees. It's a form just for your ideas. So for things that you would like, whether it's content, event, something else, if you have ideas for what will help us achieve this mission, or that would benefit you in your journey, I would definitely encourage you to pop it into that form. You all have incredible backgrounds. You've had an incredible journey, incredible story, and it's really kind of a disservice not to introduce you in full, except for the fact that all of your time is valuable. So we'll cut to the chase and have each of you introduce yourself, and in the process, maybe start to tell this story, because the first question that our members wanted to ask was a bit of the story of what led you to your current role and your desire to pursue the academic or the industry route. But maybe by way of your story, which we can allot time for, you can get at that question. And I think I will mute myself, and then the unmuting will be the signal that you're ready to talk. So feel free to jump in and proceed. Is there anybody who wants to kick us off? All right, Karen, thank you.
Hi, everyone. Thanks for having me. It's great to see so many of you attending this panel because I never had anything like this as a high school student or an undergrad. So this is really cool that this is out there. So to tell you the truth, I had no idea what I was doing. My parents were immigrants. So both my parents worked full time. I was basically raised by my grandmother. My mom went to high school. My dad went to vocational school. But I did have cousins that went to college. So I knew college was something to do. I was born and raised in New York. So I actually went to a state school, Stony Brook University in Long Island. It was that nice distance away where I can live away from home, but still come back on the weekends if I wanted home cooked food. Stony Brook University was pretty awesome because they had a very supportive system in place. There was a WISE program, Women in Science and Engineering, that already provided a network for me when I was a freshman. It also had research intensive programs as well. So I actually cold walked into a chemistry professor's office. Please don't do this. But I just walked in there with no scheduled meeting in place. But this professor, Benjamin Shao, he took a chance on me and let me work in his lab for 4.5 years. He was a polymer scientist and he electrospun for water filtration purposes and for tissue engineering purposes as well. And you know what? I thought that was really cool. So I worked in his lab for 4.5 years and decided that, you know what, let me try going to grad school. It's one of those like sheer stubbornness type of things where no one's going to say no to me right now. I'm just going to keep going. I have no idea what's going on. So I went to grad school. I applied to a few places. I got into Cornell. I visited. I loved my visit. There were a lot of really cool people that I met. And that is really important, I think. Having a network of grad school peers is really important in making sure that your grad school career can go really well, because these are the people that you are going to get advice from. These are the people that you can rant to or enjoy a nice glass of wine or something, or go out to happy hour with after a frustrating day in lab. Again, I had no idea what I was doing, but I still thought research was fun. I thought the questions that were being asked were fun. So I decided to do a postdoc. I went to conferences. I networked with people that I met during the conferences. So what actually happened was I presented at, I think it was NEBEC, the Northeastern Bioengineering Conference. And I actually gave a talk before my postdoc advisor, Jeffrey Fredberg at Harvard University. And he was really impressed with my talk and we chatted for a little bit afterwards. Now, all of this was spontaneous, so you have to be open to opportunities. And you know what? I was in my 4th year at that point. I wasn't ready for a postdoc, but he was like, you know what? When you're ready for a postdoc, come talk to me. I was like, wow, all right, I guess this is happening then. So when I was coming closer to thinking about my defense, I reached out to him again and asked him if that offer was still on the table. And it actually was. So this is one of the things where it's like one thing kind of led to another. And it was just like, right now, I guess I'm just going to keep going as far as I can and see what happens. So being in Jeff's lab also opened up a lot of opportunities. I met more people. So I went from tissue engineering to biomaterial science to biophysics. And now I'm an assistant professor of bioengineering at Temple University. I never left the Northeast, by the way. Stayed very close to home. But yeah, that's basically my life story right there. It's just sheer stubbornness, and no one stopped me yet. So I'll try to go as far as I can, I guess. All right, I don't know if someone else wants to go next, but everyone's kind of muted.
Okay, I guess I can go. I don't know if so hi, I'm Teresa. I don't know if my screen is showing, but so I'm Teresa Hamill. I got my PhD in physics from the University of California, Davis. And before that, I studied physics at Penn. And I guess my story, and now I'm working as a data scientist, so I'm one of the people who transitioned into industry. So my story really starts with just like loving physics from the time I was probably like 16. So I read some physics authors. Richard Feynman had a big impact on me, and I just loved physics. I loved figuring out what the problems, like how to find out what's like they were like little puzzles. Like how do you find out what's making the universe do what it's doing? So that was sort of my story, and I just love physics, and I knew I wanted to stay in physics. And then coming to like the fourth year of my 6-year PhD, which is pretty typical in physics, I sort of realized that I wasn't feeling as much fulfillment in my work. And I think part of that is where physics in particular, I say theoretical physics, but where theoretical physics in particular is today, fundamental theoretical physics, because basically, I don't know how many of you are familiar with the field of physics, but basically, physics currently has we've pretty much explained most of the experiments that we've done. So most of like fundamental physics, like so things on the very small scales and the very large scales, like I don't know if any of you have heard of the Higgs boson or things like that. Like we have pretty good theories for a lot of physics. So if you create a new theory, because pretty much all of experiments are already explained, you have to wait for new experiments to come out to test your theory. And that's going to take like 50 years. So I think I was just sort of coming to terms with the fact that you might not in your lifetime see any impact from your work. So that's very specific to physics. And I know that there's still people doing really important work in physics. And just because something takes a long time doesn't mean it's not important. But for me, I wasn't feeling as fulfilled. So I started to look for other jobs outside of physics, and sort of had no idea because I was so gung-ho. I love physics. That's all I want to do. So I kind of just got an internship in finance because I had heard a lot of people in theoretical physics go into finance because there's a lot of math in both things. So it was very just sort of going with where I thought I could get a job more than where I was very passionate about. Not that I wasn't interested in finance, but it was just sort of, I thought I could probably get a job. So I got this internship. But the particular finance internship I got really worked out well because it was an internship with a startup that traded stocks using machine learning algorithms to sort of tell them which stocks to buy and which to sell. And there I discovered machine learning or data science. And that was really good for me because I found that to be really fun. A lot of what attracted me to physics is like solving problems using like technical skills and knowledge. And a lot of that is the same parts of your brain are being used in data science. You're just solving usually business problems rather than theories of how the universe works. So then from that internship, I went to the Insight Data Science Fellowship. If any of you are in college or in science grad schools, you might have gotten emails from these people. It's a common, or it's a pretty well known, I guess, at least among a few fields where they advertise a lot, data science fellowship. So if anyone has any questions about that, I had a really good experience there, and from this data science fellowship that sort of trains you in how to transition from academia to industry, as well as skills specific to data science. I really had a good experience. So if anyone wants to contact me later about that. But from there, I applied to and got a position at a company called Air Liquide in Delaware. And just a little bit about Air Liquide. Air Liquide sells industrial gases, so oxygen, nitrogen, things like that. It's a very big company, but no one's ever heard of it because nobody buys these things although actually probably some universities have Air Liquide as their like nitrogen supplier or something. But anyway, so it's a really big company that's very old and is now trying to transition from traditional business methods to more, data-driven methods. So it's very interesting, and I really find that exciting, because in data science there's kind of different concentrations or kinds of positions. Some positions are you're working at a tech company and you're working with 100 other data science or machine learning engineers. So you're working on small pieces of big problems that are doing like things that have never been done before. But there's also the kind of data science position where you're working at a company where maybe they're not going to have the most advanced data science algorithms, but the data-driven methods that you use, even if they're pretty simple, they're going to have big impact because it's a big company that really hasn't updated yet. So for me, I really wanted to see the impact of my work. So I really like working at this kind of company. So I guess that's it for my background.
Awesome. Thanks, Teresa. Anyone want to jump in next? Bushra? All right.
Sure. Hi, everyone. My name is Bushra Bataine. I grew up in Jordan, and Jordan has one of the most severe water crises in the world. It's one of the poorest countries in the world in water resources per capita. And that was kind of in the back of my mind, but I didn't know what I wanted to do when I went to undergraduate, and I went to UC Santa Barbara in California, which was mostly in-state students. So it was a bit of a culture shock for me, but allowed me to really appreciate California, spend Thanksgivings with my friends' families, and really learn to love it. And by chance there was a new interdisciplinary major called Hydrologic Sciences and Policy. And I think when I went in undecided, I was taking a range of classes. And as soon as I figured out that what I wanted to do was close to environmental engineering or civil engineering, UC Santa Barbara doesn't have that department. And so I didn't want to leave. I had just gotten over my culture shock, and I made my group of friends. And so when I found out about this hydrology program, there were 6 people in it. I was thinking, I grew up very aware of water scarcity and water resources issues. It seems like a really great major that combines mechanical engineering, environmental studies, environmental history, and so geology, etc. And so since then, I've become the water person and didn't really look back since. That said, I never really considered a career in academia, but after I finished my bachelor's, I went back to Jordan and was working, and realized that within the water field, it was very bureaucratic, pretty male-dominated. And I remember thinking to myself, I want to be as qualified as I can and have all the sort of stamps near my name to be able to maximize the chances that I would be listened to and have an impact on improving the water situation, especially in Jordan, but elsewhere as well. And so that I kind of went into grad school with that mindset. And then when I went to Stanford, I was doing fluid mechanics and hydrology and decided to stay for a PhD. I was a little bit undecided, but kind of knew that I would like to pursue a PhD, but knew that academia was more likely than not for me. I never really considered an academic path. So I tried to leverage the PhD to kind of get a range of skill sets that I could then translate into industry. And it doesn't have to be as deliberate or pre-planned. Definitely along the way, I was like, do I want to be a professor? Maybe. But for the most part, I was pretty decided. And the way I did that was take a bunch of classes in other departments. I was very open with my advisors about the fact that I was leaning towards a career in industry. And I leveraged summers before my intense sort of dissertation writing summer to do internships, tried consulting, I tried engineering, I tried finance, I tried starting my own company, and then eventually joined the company that I currently work for, which is Bechtel. It's a large US construction company that has a water business line. And I joined their finance and development group because after finishing my PhD in design and construction of water infrastructure, I wanted to kind of get more into the finance and development side, because I increasingly realized that while a lot of water projects might make sense from an engineering perspective and a sort of societal benefit perspective, if the money's not there, it's very hard to build it. So I'm currently working on that. I'm London based, so it's late evening my time, but I'm super happy to be here. And it's been fun. So that's my story, and happy to answer any questions.
Wonderful. Thank you so much. Ritu or Irene?
Ritu, you can go ahead.
We're already unmuted. But all right, fine. I will let you wrap up with a bang. Well, hello, everybody. My name is Ritu, and I'm a postdoc in the same lab that Alice is in, actually. So she actually started right around the time that COVID started. So I very rarely see her with her mask off. So this is very exciting for us. But yeah, I mean, I actually see a lot of similarities between my story, I think, and a little bit of Karen's and a little bit of Bushra's. But I was born in India. I lived in Kenya for a while. I moved back to India and then moved to Philadelphia, Iowa, Connecticut, New York, Illinois, and then here to Boston. So I haven't lived anywhere for very long, and I went to 10 schools before I got to MIT. So I've had, a pretty unusual, I would say, experience of sort of bouncing around between schools. But one thing that you kind of learn going through this experience is that a lot of stuff changes in schools all around the world, but math and science stay pretty consistent. So it's easy to stay on track with that, even when it's hard to keep up with everything else. And also my parents were engineers, and I saw some of the really great stuff that they were able to do for their communities using their engineering degrees. And so I kind of thought, that's probably what I wanted to major in. But because no one in my family had been to college in America before, didn't really know how to go through that process. And I was at a sleepover, and I overheard one of my friend's older sisters say that Ivy League was a good thing. So my college application process was to apply to every school that said Ivy League on it. And luckily I got into Cornell. That was kind of a dangerous strategy. So that was a lucky break for me. So I got into Cornell, which was great. It's a great engineering school, great school in general. But I, being an immigrant, I was on a dependent visa. And so I couldn't actually do any jobs or internships. I wasn't eligible for most things. And so I would just try to scrounge up doing any kind of job, not even really related to what I was learning in my classes. I was a mechanical engineer because I thought I wanted to be an astronaut, and that seemed like a path to get there. But I did all kinds of jobs. I worked in biology labs, feeding their rats and putting them on little treadmills to simulate exercise. I worked on water treatment plants because when I was a child in southern India, I experienced a lot of droughts and water shortage. So I was like, that's kind of interesting. So I would do anything for a volunteering basis, basically. And then I found out about this fellowship that was giving $16,000 to students to learn about entrepreneurship and place them in any kind of startup that they wanted. And I applied. I had always selected out of these opportunities because I'm like, I'm not eligible because I can't earn money. I just applied for the fellowship. I went through this like super intense round of interviews. I got it. And then I was like, hey, can I still do it? But don't give me the $16,000. And they were kind of like, what? But they let me do it, which was great. And I wish I had thought of this before. Turns out occasionally people will be happy to not give you money. So then I went and worked for a startup, and it was a fun job. It was like I had learned a lot of things about biomedical engineering in my classes, and it was a startup in the biomedical engineering space. And I enjoyed my experience there, but I realized that everyone there who had the kind of job that I thought was really cool had a PhD. So I was like, I need to go get a PhD. And very luckily around that time, I ended up attending a free seminar, much like this one, where they told me that a PhD doesn't cost money and that you get paid to go. And so I knew that it wouldn't be a financial burden on my family. So I applied and I got into Illinois, and that was a great thing. And went to grad school. It was fine. My plan was to get out and go join a startup and be a CSO of a startup, or go work for Stryker, which is a medical device company, in their R&D arm, because that's where my dad works in the supply chain department. So that was my goal. But turns out that I was like pretty good at grad school. I just really enjoyed it. I loved coming up with new ideas. And, after I finish a project, I'd come up with more new ideas, and people were like, you should really be a professor. Like, this seems like something that you should do. And I was like, okay, because I don't know, like sometimes like some of the people said, like you get set on a path and it just keeps speeding this process. And I knew that I wanted to do more stuff that was relevant to the clinic, relevant to like medical devices that are actually being put inside people. And people kept telling me you should go work for Bob Langer. And for those of you who don't know, he's a really famous engineer. He's the most cited engineer in history and probably the most famous biomedical engineer there is. And partly responsible for the Moderna vaccine, if that's something that you guys have heard about. But I was so nervous. I was like, why would that guy ever want me in his lab? So I didn't even apply. I self-selected out, which is probably a classic woman move that I should avoid. And I didn't apply, but my boss applied for me. He emailed Bob and was like, I have this great person, and, if you hire her, you won't regret it. And Bob is very well known for responding to his emails very quickly. So he responded within 30 seconds and was like, sure, we'd be happy to have her. So that's how I got my job. And I showed up here. And I have learned a lot actually over the past few years, not only about the academic path, which I'm currently on, establishing my own lab and doing research, but also about other paths that I think are actually really interesting and I never had exposure to before, like spinning out my own company, like starting my company rather than joining a startup. Investment in startups. There's a lot of different opportunities that I never heard about before that I've learned more about here. And I think that while they haven't changed my mind too much, they have strengthened my conviction in the fact that I want to build a really clinically relevant lab, preferably immersed in a hospital setting. So that's where I am right now. And hopefully I'll be transitioning to one of those roles very soon.
Wonderful. And there are great questions coming in through the Q&A function, but I guess, Ritu, I can knock this one out while we're at it, because people want to know what tea you're drinking.
Oh yeah, it's Pukka 3 cinnamon, and I recommend it for people who are on Zoom all day, because if you're talking a lot and your throat gets sick, it's really good. Ginger or cinnamon.
Very good. Good. Glad we could answer at least one of these. Awesome. All right. And Irene.
Yay, thank you. Ritu, I just noticed that you had wanted to join in earlier, so I wanted to give you prime of place. So my name is Irene, and I am currently a software engineer at LinkedIn. And my story is really interesting because I didn't actually start out in computer science. So I really loved hearing everyone's story. I mean, I can resonate with so many different aspects. So for example, I'm also an immigrant. I was born in Nigeria. My parents immigrated here. They both got their master's and PhD. So I always knew about the importance of academia and what a PhD was and what it meant. And when I was going to look into colleges, I was really interested in the brain and how it worked. And so I knew I wanted to study something called cognitive science. I went to school called Dartmouth College in New Hampshire and studied cognitive science there. Part of it was actually computer science, interestingly enough, which I wasn't going to revisit until a few years later. But in that program was really fascinating. There was neuroscience, linguistics, philosophy, just learning all these really fascinating things. And I got really interested in the neuroscience path. And so I kind of focused more on that. And my big break, I guess I would say, was learning about a professor that did this very famous, fascinating experiment about regenerating neurons, and it was called the checkerboard experiment. So we put integrins in. So integrins are these chemicals or proteins, I would say, that cells attach to. And so we put integrins in like the lines of the checkerboard and basically plated neurons on it and saw where they grew. And you could see that they were growing where the integrins were, which was a really cool way to visualize how they work. And so I'm like, whoa, I need to find out more about this. So I actually, kind of similar to other people, cold emailed him, asked him if I could work in his lab. He didn't have to pay me. And ironically, it was actually in my home state in Minnesota. So it was at the University of Minnesota. I actually worked in that lab for two different quarters. So the first time was, I think it was my sophomore winter. It was awesome. And I got to work with these PhD students. And I was so excited to go into lab every day and do these experiments to figure out how to cure spinal cord injury. And so when I graduated, I wanted to continue on that path. So I actually did this post-baccalaureate fellowship at the Mayo Clinic in Rochester, Minnesota. And I worked in a lab that had ties to the Robert Langer lab. And so a couple of the people I worked with had worked with the Robert, and that lab actually was collaborating with a neuroscience lab. So this lab was particularly a polymer science lab. And so what we were doing was creating biodegradable, compatible scaffolds for spinal cord injury. So we were actually implanting them into the spinal cords of rats. And we could see that in some rats that it actually didn't completely regain function, but partially. And so we wanted to improve that. So that's what my job. So basically my job was to create these biopolymers that could also be drug delivery vehicles. And that was really awesome. It was super fun. But the one thing that I realized from that project, and I really loved how multidisciplinary it was. There were polymer scientists, polymer chemists, neuroscientists, immunologists, neurosurgeons, like all these different types of people coming into meetings every week. But I did notice that there really weren't any molecular biologists. So what was going on the molecular level, what was going on with the genes, with the proteins, with all these things. And so I knew that I wanted to study that more in order to go back into polymer chemistry and tissue engineering in order to add that. So I applied to grad schools and got into my dream school, Stanford, and did a PhD in molecular and cellular physiology. And it was a really great experience. But the thing that I realized as I was going through it was just all the, like, if you go to Stanford, there are just so many opportunities, as Alice knows, that you can learn, and just so many resources and so many ways to really, to just really kind of change the world. And so I realized that I didn't have to just be a bench scientist, that you could also be, go into data analytics or, just look at the world in different ways. So just to kind of make the story a little short, eventually after I graduated, I actually did some internships at health tech startups. And I think one of our panelists did an internship in a finance startup or a finance firm, and I did that too. And so just these different varied experiences. And eventually I ended up in an internship that turned into a longer term job where I did computer science almost every day. chemistry. And that really ignited a love for computer science, which is interesting because when I started out in undergrad, like that was part of my my undergrad degree, and now I was using it again. And now I'm a software engineer at LinkedIn, actually doing a lot of back-end infrastructure for artificial intelligence and machine learning. One thing I didn't mention was that my undergrad degree in cognitive science was artificial intelligence, but I kind of went into the neuroscience direction. So it's really interesting how life really goes full circle sometimes. But touching on industry versus academia, one of the big lessons I learned about going into an industry profession from academia, especially after getting a PhD, is just how valuable and useful that experience is. Because in a PhD, you just really learn how to think outside the box, how to think creatively, how to think in ways that other people typically don't, because you can't usually always just go with plan A. You need a plan B and a plan C and a plan D, and just think of all these different ways to solve a problem. And that has come in so many times where our team was blocked on something, but I was able to propose a solution that actually worked and saved our companies like tons of money and tons of, just tons of work because of these like kind of, I wouldn't say simple solutions, but things that people just didn't think about. So that part I really appreciate about getting a PhD. And also the other thing that seems kind of obvious, but is so important is that in a PhD, you learn how to really learn new things quickly, because when one experiment doesn't work, you need to do another experiment. If you've never done it before, you got to figure out how to do it within a week because you got to do that experiment. So you just learn how to think quickly and think on your feet. So both these things, and I'm sure a ton others have been incredibly valuable going into industry from a PhD.
Wonderful. Thank you so much for that. I think these stories are really so incredible, and you guys just shared so many different insights within all of that. So that was really rich stories. And so I guess as a bit of a roadmap now that we've done a bit of this introduction and you guys have shared so much, we'll zoom briefly in on academic routes in particular, and then we'll zoom in on industry corporate routes, and then we'll kind of wrap it up with the pros and cons, if there's anything to add, and then a round on advice that you have to share. And so to start this on the academic route, I guess to Karen and Ritu, what are some of the main things that a person should keep in mind before focusing on an academic path? And who are the types of people, if you've noticed any kind of specific characteristics that you have seen flourish in academia?
That's multifaceted. There's a lot to unwrap there. Okay, so actually, why don't I first talk about the types of academic paths there are, because even with going towards a professorship position, there are many different types of professorships. So I am in a state school. I teach. I have a 9-month salary because I teach each semester. And I knew I wanted to do this because during my PhD, I also had teaching fellowships. I TA'd. I had an NSF teaching fellowship where I worked with local high schools, local 8th grade and 9th grade students to help enhance their STEM curriculum. And I really enjoyed that. I've always loved mentoring students. I always loved teaching. Then I went to a postdoc, and my postdoc lab was actually in the School of Public Health. My advisor worked on lung mechanics during my postdoc, so that's why he was in the School of Public Health. But in that department, I realized that I was isolated from all students. There were no high school students, no grad students, no undergrad students. And I was like, oh, this is kind of weird. It's just mostly postdocs and other research scientists. Now, that was great because there was a lot of really fun research happening, but I clearly felt that gap. And so when I applied to faculty positions, I knew I wanted to focus on applying to schools where I would do part-time teaching as well. Now, even in different universities, you have places where they're more research focused or they're more engineering focused, or you have other research institutions like, what is it, Fred Hutchinson or the Fox Chase Cancer Center, where these scientists are what you would potentially consider as soft money. So most of their salary comes from the grants that they apply for. So they are focused on the science. They do have students and postdocs and research scientists in their labs that are generating all that preliminary data to publish and to apply for grants. But there are differences. So I have to write grants as well. I have undergraduates in my lab. I have a grad student in my lab. I'm hoping to get postdocs soon, but there are a lot of nuances in just academia alone. And Ritu can probably also see the differences because you're at the Koch Center and that's completely different. But you guys also get students, I believe, from MIT. Yeah.
Yeah, no, I think it's really helpful to landscape it that way because that's not something that I fully understood. I think for a long time, even your interaction with a professor as an undergrad is people teaching your classes, and you don't realize that a big part of their job is actually running a research program, getting millions of dollars from the government and publishing papers and doing all this stuff. So it's really important, I think, first part of Alice's question, like what to think about going to an academic career is to really scope out, maybe talk to a lot of different professors, both at your university and other places, if you have opportunities to go to panels or interact with them in some sort of formal way, like informal way, like signing up for lunch with them or something, figure out what their day-to-day is like. And you can kind of get a sense of like, what are the types of things that you can do as an academic? And then in terms of research, you can also, I think you should just try a lot of different things. I mean, I think Karen was really lucky that she found a lab that she wanted to stay in for 4 years. My experience in undergrad was very different, where I did try to work in a few different labs and actually didn't enjoy most of the projects that I worked on, except for the very last one. But that ended up sort of shaping a lot of what I did in the future. So trying a lot of things can be very helpful because even if it doesn't tell you what you like, it'll tell you all the things that you hate, and then you can narrow it down. I also wanted to answer, I think the second part of your question was what kinds of people do well in academia. And one, I think it's very dependent on the path, right? There's a lot of different types of paths. So there's many people that are suited to it. But one thing that I think is fairly common across people is academia involves a lot of long-term goals. You're starting from the very basic science of something. And sometimes, especially for biomedical work, if I'm thinking about something that's clinically relevant that I'm going to put as an implantable device into a human being, that might take, 10, 20, 40 years to do. So you have to be the sort of person that's like very okay with that and can keep excited about something and working hard at something, even knowing that it's not going to be a product that you're selling on a website tomorrow. It might take a longer time. So I think people who are persistent in the face of long-term goals tend to be pretty good, or at least happy at academia.
You also have to be very comfortable with being uncomfortable, if that makes sense, because we are pretty much flying blind. We are asking questions to which there are no answers to. So we have to be comfortable with not knowing the answers and troubleshooting all the time. And so growing up, I was a menace because I would always be taking stuff apart in my household. I would maybe half the time be able to put it back together, but this is pretty much what continued me into the bioengineering field. And it is very multidisciplinary. You have to kind of think with slightly different concepts. So material science, polymer chemistry, biophysics, cell biology, and put that all together. No one is perfect and no one has all the expertise. So a lot of this work is team-based. So for those students that are undergraduates, your senior design projects are a great experience to learning what research could be like, because you are holding down on a question and you are breaking that down into smaller pieces and working together with other students who may be from different backgrounds, material science, mechanical engineering, bioengineering, and whatnot, and working together to have a final product. Now, a few soft skills I actually didn't mention before, but you should be always open to networking, because these are people that are, I have met so many people just randomly that have been super helpful. I've met people who are peers for the next step in my transition. So for example, going from undergraduate to graduate, there are people who are a few years ahead of me that told me this is what I did, this is what worked for me, this is what didn't work for me. Same thing from grad school to postdoc. Now, no one's experiences are the same, and that's why you need to be able to get a lot of stories so that you can see what might be best for what works for you. I have two other things if there's time for that. Another thing is also a lot of public speaking. I'm an introvert at heart. I would love to just be home all the time, but you have to be able to communicate your ideas, whether that's in academia or industry as well. So public speaking is something that if you have opportunities to practice with, please do that. Writing is also another very important skill to have. Nothing is ever going to be perfect, so don't let that paralyze you. Just word vomit onto a document and then go back to it. Walk away, go back to it again. Science communication is really important, and our ability to be able to convey everything from what's up here onto to an audience or onto a piece of paper is very important to be able to continue the science along. And not to get political about it, but science literacy is something that's really important right now, and that's kind of an issue. And I'll stop there.
Wonderful. Awesome. And I think in the interest of time, I'll jump into industry. I was tempted to do pros and cons with that now, but I think I'll jump into industry, and then we can take some Q&A questions that are bubbling there with votes. So, but to kind of set the stage for industry corporate routes, what do the rest of our panelists have to say about that, and things that people should keep in mind in that path, and then characteristics, anything that jumps out to you?
I think I can speak a little bit about it. I think one of the things that for me was pretty different, also it might be because of the part of STEM that I was in. So I was a theoretical physicist. So if I worked with a group, it was like 2-3 people, and we would talk about theories and then go write the calculations on Earth. So it was very much like you worked with a team, but it was a small team, and you pretty much all had the same skills. One thing that I've noticed coming into industry that is a pretty important skill, which it is important in academia too. You do have to convince people that your grants are worthwhile and things like that. But for the most part, you're working with people with similar skill sets to you, I would say, day to day. Whereas in industry, you can be working daily with people who have no idea the technical detail of what you're actually doing. So it becomes very important to be able to communicate as much as you can, because sometimes you can't. If somebody can't understand a certain thing, they might not be able to understand it, but you have to communicate like the why, the how long. So for me, that kind of communication to business stakeholders, to people working on your project who don't have the same skill set, that becomes very important. And I guess another thing that sort of goes along with that, and I think this sort of goes with something Karen touched on, I think a little bit of the length, or no, it was Ritu, that the length of the project. I guess in industry, your motivations might change a little bit. You're not working on these big, well, you might be working on some really big things, but for the most part, you're working on smaller projects that are not like, you're not, the goal isn't as lofty, but the steps might be a little bit smaller. So yeah, it depends on what you're motivated by, I think. Okay.
I'll go next. So I wanted to touch on one point that I actually saw in the Q&A about creativity in academia versus industry. And I'd love to have anybody else jump in and, counterbalance what I'm saying. But the thing I did worry about, and things I've heard or did hear when I was in academia was more creative. Like you had more freedom to take risks and do things like that, and you would have less freedom to do that in industry. Now, when I was in academia, I was in the biomedical sciences, and now I'm more in software engineering. And those who are in a more biomedical science industry role or science industry role, I would say, can jump in. But I've actually noticed that creativity is very valued in industry as well. And that a lot of companies, for example, you hear about Google giving people 20% time to work on projects that are just fun for them. And if they become something that the company will use, that's great. If it doesn't, that's fine too, as long as you're continually growing. And so I think that idea of, thinking outside the box and just looking at things in a different way is valuable in either space, industry and academia. But again, I'll offer anybody else to jump in on that as well.
I would just second that. Even my company, I said it was like not a data-driven company at all. They do give us, I think we're 10%, but really it's varies between 10 to could be 50%, depending on how useful the project seems. But we have a self-driven project too, so it's not just at Google.
I would echo both, and I'm in a large construction company that's pretty traditional, so I feel like you would think maybe slow moving or not creative, but I haven't found that to be the case at all. And we spend about 20% of our time trying to think about future of construction, what projects we could be developing. And I find myself kind of repeating a lot of the creativity and entrepreneurship sort of training that I got to be part of during my PhD in a work setting, including things like, brainstorming and reframing the problem. And as scientists and engineers, that's problem solving focused. And I feel like it's relevant regardless. And you always find peers that are innovative and creative. And so I think regardless of the context, that's the case. And then I think to kind of things to keep in mind for industry, I think it really depends on the type of role. So I think when I was trying to do startup, it was very flexible, but sort of all consuming. And I think there's more structure in my current role within sort of a large construction company. And I think one other thing that I wanted to flag, and I would be curious what Irene and Teresa have to say about this as well, but in industry, opinions are very valued. And I feel like as an academic, I feel like I have to caveat and explain all the uncertainty around my statements. And it's tricky. It's tricky to find the balance between presenting opinions and saying them with confidence, but also kind of highlighting the limitations. So I found that to be an interesting thing in industry versus academia, how you communicate and what type of statements are valued sometimes.
Yeah, I will totally echo what you said, Bushra. Absolutely. And I think I see myself kind of falling into my academic ways sometimes when I explain things, like always explaining like the caveats and things like that. And so maybe that's something I need to work on, being more direct in my opinions.
Yeah, I would agree 100%. And also I agree that it's the same case with me, that's something I have to work on, because you want to make sure the person knows exactly. Whereas I guess in industry, probably the person is more concerned about like, why does it work here than why wouldn't it work if it wasn't in this case. But so it's a lot of bigger picture communication then. But yeah, that's totally true.
Very good. Do either of our academics here want to chime in on follow up on any of that conversation? this kind of gets a bit of differences between the different routes. But if you had anything to add there.
I think Karen and I were both busy answering questions in the Q&A.
Yeah, we were actually
which we're also grateful for.
answer questions. So, I mean,
nah, it's good. It's good. Okay, so let's jump into some of these questions. So the top voted one right now relates to internships, co-ops, jobs. How do you get this if you don't know somebody that works at that company? What have any of you had specific experiences, or like what would you recommend?
If you can find a faculty mentor to go to bat for you, do that, because you're right. Oftentimes you need that introduction to get your CV or resume to the top of the pile. They are looking through 400, 500, thousands of applications. And if there's anything that could help you get ahead, that's something that you should try to do. Although, speaking of, Irene, you're in LinkedIn. There are ways where you can upload your CV, right, to job openings. Do they filter a lot of these CVs? Like, aren't there terms that you should be using in your CV that help bring your resume or whatnot to the top of the pile? Am I speaking about this correctly, or am I completely left field?
Oh no, yeah. And even before I joined LinkedIn, like I knew all the tricks. Resumes. So I'm happy to like chat with anybody who is here. Just reach out to me on LinkedIn. I'm happy to help you with your resumes. But yeah, definitely using keywords, especially when looking at, let's say, a job posting and they want something, let's say MATLAB. If you've had any MATLAB experience, make sure you add that in your resume, especially on the top, because when recruiters are looking at it, they're probably going to take 15, 30 seconds, making sure that they can screen you as quickly as possible. And if there's any reason for them to not screen you, let's say you have a term that they're looking for, then definitely put that as high on the top of the page of your resume as you can. But that's one pro tip that I learned a while ago.
Yeah, I would say another thing is feel free to contact the person doing the job posting, especially if they post their email. Like, well, maybe Irene can let me know because she works at LinkedIn. But I feel like the more you can do to make yourself be a real person rather than just a piece of paper or a LinkedIn profile, that will help. So if you just ask them, like, I have some questions about the job, or I applied, I'm really interested, whatever, anything to make yourself a real person. Also, I don't know, it depends on your university, but some universities help you with that. And even the person who works in the career thing at your university, you might not have an in, but they might have an in, or they might have worked with that company before or something like that. So definitely reach out to your university. They usually have some good resources.
Very good. So I am grateful. If anyone's not tuned into the Q&A, I would recommend going there, reading some of the answers to these questions that our panelists have been typing in, because they're really excellent. We are coming up on an hour, so I wanted to I know we're talking about a lot of diverse topics and fields, right? There's a lot in this, and I think it's been beautiful to see some commonalities come out and everyone's stories and advice. I would like to do just a final round of advice that the panelists would like to share. And then if anyone is able to, not expected, but if anyone's able to stay on and kind of answer some of these other questions here, because there's a high level of specificity that's coming out there, that would be great. But any last advice you have for the high school, college, grad student, young professionals that are listening? You can take the floor.
Have fun. That I'm totally serious. Definitely make sure you're having fun, because if you're not, you are going to be miserable beyond belief. I am having fun doing research. I think I answered it in one of the questions, but I really like eating. I really like traveling. And as an academic, I can apply to present at different conferences and really cool places. So I went to Turkey. I ate really great baklava there. I went through the mosque. It was a beautiful area. So these are things that if you can figure out a way to combine it, do it. But my path is just one little path. There's a lot of other interesting paths out there. And so just don't be afraid to fail and just try to keep going and find mentors that'll be your cheerleaders. I had a lot of great mentors over the years.
Yeah, I would just echo that. Like, don't be afraid, try different things, and do what you really feel called to in the moment. And it doesn't have to be that forever. No school, no job has to be forever, but you can try it and learn a lot.
I guess my piece of advice would be don't be afraid if your interests change. So I went into undergrad thinking I wanted to do kind of science, got really interested in neuroscience, went to grad school for molecular biology, and now doing software engineering. And all of those paths have been really, really fruitful, and I've grown a lot. And I can see myself in the future potentially combining the computer science with the molecular biology in order to do something in that intersection. And so nothing ever goes to waste. Every experience just grows yourself as a person and also reminds you of what you're capable of. And so never feel discouraged if somehow you feel like you're at a crossroads. Take the path that really excites you and see where it leads you.
I like to go for it. I always stop at the right point. I would say my advice is I always tell people don't focus on like following your passions. And that doesn't mean to say, don't do something that interests you. You absolutely should, but don't do something solely because it interests you. You should always focus on whether the thing you're doing provides like a useful service or product to other people. And that's for two reasons. One, I think you'll leave you'll end your day and your life feeling more fulfilled. But also people will pay you if you're doing something useful, and being paid is kind of important part of survival. So that's what I always tell people, don't just follow your passions, think about how you can be useful to your community.
I totally agree. And I think don't be afraid to try different things, like Irene said, and like everyone else said. It's really interesting to pursue something that you're not sure why you're interested in, but just I feel like the most valuable thing we have is time. And so what you choose to do with your time and maximizing your usefulness is really cool. So I took a bit of a tangent with the startup and did modular construction for refugee communities, and it was unrelated to hydrology, but I wouldn't change it for anything. And so, you know how they say looking back, things all fall into place. I'm not quite sure how it's all going to fall into place yet. And I think Irene kind of mentioned similar, like how it might tie together in the future, but you never know. And I would say try as many things. And I think one of the panelists mentioned before that worst case, you find out that you don't like something, and that's also really valuable. So you don't spend more time on that.
Wonderful. Well, thank you guys so much. Big thank you to our panelists, and thank you to the attendees for coming. This is really great discussion, and maybe this is just part one of many more to come to kind of parse apart different aspects of that, but this was really fabulous. So thank you all, and I hope to see you next time.
Thanks, Alice.
Thank you, Alice.
Yeah, thank you guys. I'm going to answer some of these questions here. I'm going to prioritize people that are non-anonymous and are still around. So if you asked a question and you really want it to be answered, maybe you can put a message in the chat and I can give that priority.